Hello everyone, welcome back. Here's Van Amsen, and today live coding session we will tackle an exciting problem related to spells and potions. Let's get into it. All right, let's first get a grasp of the problem. We have two arrays, spells and potions, representing the strength of spell and potion respectively. And our goal is to find the number of pairs between each spell and the potion such that their product is at least a given value. Success. Sounds magical, doesn't it? So let's take a moment to think about the problem. Any initial thoughts or question? Okay, so if we are thinking that this problem might involve some sort of search or pairing, you are on the right track. So the first thing we notice is that if we sort the potion array, it will make our job easier. Why? Because for each spell, we just need to find the first potion that makes a successful pair. And since our potions are sorted, all potions after this first successful one will also form a successful pair as well. So let's dive into code. So first thing first, implement sort the potion array. So potion sort. So we begin by sorting our potion array, and this will help us efficiently searching for the right potion for each spell. So let's move on, and we need an array, say a result, to store our result for each spell. And we also store the length of a potion array in M for convenience. So result M, then potion. Now for spell in spells, find the first potion such that the potion spell and potion is at least a success. So now for each spell in our spell array, we want to find the first potion that can form a successful pair. And this is where the magic of binary search comes in. Let's implement it. So index bisect left potion success spell 1 if success modulo spell not 0 else 0, and calculate the number of successful pairs with the current spell. So here we are using the predefined bisect left function from the bisect model, and it efficiently finds the potion where we can insert the required value to maintain the sorted order. And I see so why we are adding 1 sometimes in our search value. So great question. So this is to ensure we are searching for the ceiling value of the division, ensuring that our product is always greater than or equal to success. So now let's calculate the number. So it will be result append m minus index and return a result finally. So lastly, we compute the number of successful pair for the current spell by subtracting the found index from m, and this gives us the total potion that can pair successful with our spells. So let's run it for given examples to verify it's working. So yeah, with spells 5, 1, 3 and potion 1, 2, 3, 4 sorted. Yeah, success 7 and output as desired. Okay, so all good. Now, yeah, our solution works. So let's submit it for unseen test cases as well to verify it's work properly. So yeah, all good. And we beat 56% with respect to memory, but yeah, 92% with respect to runtime. So quite good. And that's it. That's our solution, quite optimal, with a sorted potion array and binary search. And we have made our solution both efficient and quite elegant. So not yeah too long implementation, but efficient one. So I hope you appreciate this example. And all right, it was a really magical journey solving this problem with all of you. And always remember, coding is like casting spells. So with the right algorithm, you can create magic. So thank you for joining in for today's session. And if you learned something or want to see more tutorials, machine learning, tech, and much more, please yeah, like and subscribe for more, and keep practicing. Happy coding, and see you next time.